Hello grade 10 students. Welcome to another virtual class. I am Miss Madhu Vadke. We are studying chapter 6 triangles and we are learning how to apply Pythagoras theorem in various types of problems. So let's continue with solving questions of exercise 6.5. We have finished first 6 questions, so let's continue with the question 7. Prove that the sum of the squares of the sides of a rhombus is equal to the sum of squares of its diagonals. We are given a rhombus in the question. So let's draw a rhombus. Recall, a rhombus is a quadrilateral in which all sides are equal and opposite angles are equal. So let's name this quadrilateral as ABCD, in which all sides are equal. So we are given that ABCD is a rhombus. And since we have written rhombus, we should know what are the properties, that AB equal to BC equal to CD equal to DA. We have to prove that the sum of squares of sides AB square plus BC square plus CD square plus DA square is equal to the sum of the squares of its diagonals. The diagonals are BD and AC. So we have to show that this is equal to AC square plus BD square. Since ABCD is a rhombus, we have to make use of its properties. The diagonals of a rhombus will always bisect each other at right angles. Let's write down this property. We have studied this in grade 9 in chapter quadrilaterals. So, if the diagonals are cutting each other at point O, then we can say that BO is equal to OD and AO is equal to OC. So now consider this triangle DOC. In this triangle, angle DOC is 90, so this is a right angle triangle. So we can apply Pythagoras theorem to its sides. We get OD square plus OC square equal to DC square. But OD is equal to OB. So we can write OD as half of DB. OD is equal to OB and both can be written as half of BD. Similarly, OA is equal to OC and each can be written as half of AC, because OA plus OC makes AC and OD plus OB makes BD. So now we can substitute in the above equation OD as half BD whole square plus OC as half AC whole square equal to DC square. We can add here OA equal to OC and OB equal to OD. On squaring, we get 1 upon 4 BD square plus 1 upon 4 AC square equal to DC square. Taking 1 upon 4 common, we get in the bracket BD square plus AC square equal to DC square. Taking 4 to the other side, we get BD square plus AC square equal to 4 times DC square. So BD square plus AC square equal to 4 times DC. I am going to split and write as DC square plus DC square plus DC square plus DC square. And since ABCD is a rhombus, we know that AB equal to BC equal to CD equal to DA. So now what we can do is replace the first term here with AB, replace the second term with BC, the third term we will leave as it is, and the fourth term we will replace with AD because all of them are equal. So we get BD square plus AC square equal to AB square plus BC square plus CD square plus DA square. And hence we have shown that the sum of the squares of the sides of a rhombus is equal to the sum of the squares of its diagonals. Question number 8. In the figure, O is a point in the interior of a triangle ABC, where OD is perpendicular to BC, OE is perpendicular to AC, and OF is perpendicular to AB. What we have to show is clearly stated. Let's write down what is given in the question. OD is perpendicular to BC, OE is perpendicular to AC, and OF is perpendicular to AB. Now observe in the expressions we have OA, OB and OC. This means that we need to join points A, B and C to point O. Now looking at the terms in the expression, we will decide how to start the proof. Since there are right triangles in the figure, we have to make use of Pythagoras theorem. But there are 6 right triangles. So we have to identify which triangles to be used in order to get the first equation. To understand that, look at the terms OA, OB, OC. OD, OE and OF, and AF, BD and CE. AF, BD and CE. This means that we have to use the triangles AFO, BDO and ECO. So let's use these triangles one by one. In triangle AFO, which side is going to be the hypotenuse? Since this angle is 90, opposite to it is hypotenuse, so OA is hypotenuse. So OA square should be equal to AF square plus OF square. Let's take the other triangle, triangle BDO. The hypotenuse will be the side opposite to the right angle, so BO. So OB square will be equal to BD square plus OD square. Likewise, in the third triangle CEO, the hypotenuse will be opposite to the 90-degree angle, which is OC. So OC square will be equal to CE square plus OE square. Now let's add all these. So we get OA square plus OB square plus OC square equal to AF square plus BD square plus CE square plus OF square plus OD square plus OE square. Now let's take these terms to the left hand side. So we will get OA square plus OB square plus OC square minus OF square minus OD square minus OE square equal to AF square plus BD square plus CE square. So this is the expression that we have to show in the first part. Now to show the second part, we will have to pick up the remaining 3 triangles. As AE, CD and BF are the terms of this expression. Let's mark the triangles that we are going to use now. Each triangle is a right angle triangle. So let's use Pythagoras theorem. In triangle AOE, again the hypotenuse is going to be opposite to the right angle, that is AO. So AO square will be equal to AE square plus OE square. Likewise in triangle BOF, BO square is equal to BF square plus OF square. And in triangle DOC, CO square is equal to DC square plus OD square. Let's add them. So we get AO square plus BO square plus CO square equal to AE square plus BF square plus DC square plus OE square plus OF square plus OD square. Now what we will do is shift these terms to the left side. So we get AO square plus BO square plus CO square minus OE square minus OF square minus OD square equal to AE square plus BF square plus DC square. Let's mark this result as 2. Let's go back to the previous result. We will mark this as 1. Now compare their left hand sides. We have same terms on the left hand side of both the equations, which means their right hand sides are equal. So we can say that AE square plus BF square plus DC square will be equal to AF square plus BD square plus CE square. This is from 1 and 2. And so we have got the second part of the question. Question number 11. An aeroplane leaves an airport and flies due north at a speed of 1000 kilometers per hour. So let's say the airport is over here. An aeroplane leaves this airport and flies due north. So north direction will be here in this side at a speed of 1000 kilometers per hour. At the same time, another plane leaves the same airport and flies due west. So west will be in this direction. And this plane has a speed of 1200 kilometers per hour. How far apart will the two planes be after 1.5 hours? So let's say after a time lapse of 1.5 hours, the planes are at points A and point B from the starting point, that is O, which is the airport. What we have to find is how far apart these two planes are. That means the distance between point A and B. Since this is the north direction and this is the west direction, the angle between OA and OB will be 90 degrees. And since it is 90, triangle AOB will be right triangle. So we can use Pythagoras theorem to find AB, but OA and OB are distances covered by the two planes. So in order to use Pythagoras theorem, we need to find OA and OB. So speed of plane 1 is given as 1000 kilometers per hour. This is our first plane and this is the second plane. And the time taken is 1.5 hours, which is 3/2 hours. So the distance covered will be OA, which is equal to speed into time. So 1000 into 3/2 gives us 1500 kilometers. Likewise, we can find out the distance covered by the second plane. So speed of plane 2 is given to us as 1200 kilometers per hour. The time taken by this plane is the same, that is 1.5 hours. So distance covered by this plane is given by OB, which is equal to speed into time, that is equal to 1200 into 3/2, which is going to be 1800 kilometers. So now we have the lengths of OA and OB. Since AOB is right triangle, AB square will be equal to OA square plus OB square. So that is 1500 square plus 1800 square. This is equal to 225 followed by 4 zeros plus 324 followed by 4 zeros. On adding, we will get 5490000 and AB will be its square root. On finding the square root, we get 300 root 61 kilometers. With this, we come to the end of this video lesson. Your assignment is question number 9 and question number 10. Question number 9 you are already familiar with. Question number 10 is a question similar to the question number 9. A guy wire attached to a vertical pole of height 18 meters. A guy wire is nothing but a strong cable that is used to erect the tents. So there is a pole which is 18 meters and this wire is attached to the pole and it has a stake at the other end. So this is the wire which has a stake which goes into the ground. How far from the base of the pole should the stake be driven so that the wire will be taut? So this wire needs to be stretched and then the stake is put in the ground. So this forms a right angle triangle where length of the pole is given as 18 meters. The length of the wire is given as 24 meters and you have to find at what distance is the stake driven into the ground so that this wire is taut, that is this distance. So we have to use Pythagoras theorem and find out the third side in this right triangle. See you in the next class. Until then, goodbye.